Okay. We're recording.
Oh. Sorry.
Yeah, something like that. Probably won't. Okay, cool. So we can just do like a normal update, right? So generally we do a daily stand-up. We should project our voice that way too, so everyone can hear. Where everyone just kind of takes some time to talk about what they did. In normal cases, just yesterday, and then what they're doing today. But because we're doing a video update, we're doing a presentation sort of, we're just going to talk about general stuff from kind of the point of what we've told the public to now. So who wants to go first?
Yeah, I can go first. Basically, we've been looking at how we can achieve a high throughput blockchain. So, we actually translated a lot of ideas into a good spec. And right now we're looking at the foundational aspects of it, what is our underlying communication layer is going to be, how we're going to deal with the database contentions and security aspects of it.
Yeah, so basically if we're going to get 10,000 transactions per second, it's really hard to do that with like one chain. And so we're experimenting with breaking up blockchains into sub-blocks, reconciling those later. And so groups of delegates can focus on these sub-blocks and then just verify the rest of them with each other. And so that's fun. The concept is that most transactions aren't going to be blocking unless they're dependent on each other. So unless you send money to somebody who doesn't have any money, who sends that to somebody else, the order doesn't matter. So we can actually process a lot of stuff just optimistically. So that's like a big sort of initiative that we're doing.
Yeah, so in that regard, I think Falcon and I and Tejas just joined us recently, by the way. Welcome, Tejas. Have kind of been building the foundation for this sub-block concept and this new kind of protocol that Raghu suggesting to us. And my kind of component has been the communication layer. So kind of building the phone lines to allow all these different nodes in our network to talk to each other. It's sort of a 5G at cilantro, so to speak. And it kind of extends beyond just allowing different nodes to talk to each other. Like within each node, there's a lot of stuff going on that are kind of isolated. Kind of like Stu was saying, you have this idea of these sort of sub-blocks where you break a block into discrete chunks. And the building of these sub-blocks all happens within one delegate, but they also need to coordinate with each other. So the communication layer kind of also encompasses that component. And that's what I've been working on.
Cool.
Yeah.
Cool.
Recently, I've been working on increasing the security of these sockets that are going underneath so then we can communicate securely. So there are as well performances that I have been working on. So it's like basically just make this thing go faster by compiling everything into Python. So then it will go faster. And I wrote some performance tests in order to test these theories, and we're getting some results. I don't know what I can say, but yeah, just leave it there for now.
Yeah, because the big thing is that where is the bottleneck, and if we can minimize the bottleneck on processing by compiling, then we don't have to worry about that. We can get the throughput a lot faster. So we have Tejas. Tejas is he's going to be working mostly on our multi-master solution. So sharding the blockchain, that's kind of step 2. Step 1 is just so that we have the blockchain stored on the master nodes. People joining and leaving the network can sync, things like that. Keeping these master nodes in check with each other. And I guess you can talk specifically about the protocols you're experimenting with.
Yeah, so the idea is to kind of effectively effectively store and like share master blocks between the various master nodes we have. I'm experimenting with Sept storage right now. There are a couple of other file systems that we can try with. I'm still evaluating and speccing out the requirements. So So yeah, that'll be it.
Yeah. I'm personally doing sort of a hybrid of development and business stuff. My most recent sort of development was into, we had the Seneca protocol working on SQL, but as I said earlier, there's transactions that would require you to lock the entire table, and so you can't process them in parallel. So like, who has the most points, or who has the most votes, that's a perfect example. In SQL, you have to go through and read every single value, but if that's not ordered properly, maybe two people are tied and then one more vote comes in, you can't count the votes before that next one comes in. So it's really hard to do that in some sort of parallel way. So we moved off of SQL into Redis, which is a key value store, so we can process a lot more stuff in parallel. What I recently did was some sort of ranked order data type, which allows you to conduct elections or rank different pieces of information on the blockchain much more easily. It's much faster. As you store information, it's a little more processing and storage to keep track of this stuff, but when you read it, it's a lot faster. And so that's an interesting innovation. The smart contracts look a lot different, but much more clean, I think, and they're much more concise. So we're going to be doing more development there. And yeah.
And I think that's it. I have a business update, but we can't really share much of it. I can definitely say that we spoke with a really big player this week, and we actually moved forward significantly on it. We continue to move forward on our other initiatives, and I hope to give you guys an announcement soon.
Yeah, we're not, until something's
solid,
yeah, but everything's great.
Excellent.
Thanks, guys.